Let's start by doing a warm-up as you would if you were in class. So pause the video for as long as it takes and do these problems and then come on back. Okay, now I'll go over them. Again, I'm assuming you paused and tried it. How many 5-letter permutations can be made from the word October? So October has 1, 2, 3, 4, 5, 6, 7 letters. And we're choosing 5 of them. So 7p5, which if you put that in your calculator, is 2,520 permutations. 25p4 is a product of integers. Basically, you have 25 and you're choosing 4 of them. So for the first one, you have 25 options, 24 for the second, 23 for the third, 22. And so that's our product of integers. So when it says write as a product of integers, you don't need to actually solve it. Just write it just like that. 11p3 is a ratio of factorials. Well, this will equal 11 factorial, because this is n and r, over n minus r factorial, which is 11 minus 3 factorial. So 11 factorial over 8 factorial. Again, don't need to go any further. There's our 2 factorials. How many ways can 7 students stand in a row? 1, 2, 3, 4, 5, 6, 7. For our first student, you have 7 options. Then you have 6, and so on. Down to the last person, there's only 1 option. This is the same as 7 factorial. And if you put this in your calculator, either way, you get 5,040 ways 7 students can stand in a row, which seems a little crazy, right? Seems like a lot. Okay, so now we'll do 6.5, which is contingency tables. So we'll talk about conditional probability. And conditional probability is a probability where a certain prerequisite probability has already been met. So we usually write it like this: P of B, A, and that line means given. So this, well, set of symbols, so to speak, means the probability of B given A. So that line means given. So 2 cards are dealt from a standard deck of 52 cards. Find each conditional probability. So the probability that second red, given the first is a 2 of clubs. So I always underline the given part. So if the first one is a 2 of clubs, we're looking for the probability that the second is red. So if the first one is a 2 of clubs and you're picking the second one, if the first is a 2 of clubs, and we had 52 cards, 52 minus 1, we have 51 cards left that we're choosing from. Out of those 51, we have 13 diamonds and 13 hearts. So we have 26 options. So our probability that the second is red, given that the first is a 2 of clubs, is 26 out of 51. Probability that the second card is red, given the first is a 2 of diamonds. So if the first one is a 2 of diamonds, we had 52 cards, we drew 1, so we still have 51. But now we have only 12 diamonds left and 13 hearts. So 25 over 51 is the probability in this case. And the change here was that the first card was red. The probability that the second is a club if the first is a red. Well, if the first one is a red, it doesn't matter what it was. We drew 1 card, so we have 51 left. clubs, we have 13 clubs. We haven't used any yet. So our probability is 13 out of 51. Now we have contingency tables, aka two-way tables. And these are tables that organize two pieces of information about the same group. So for example, a study from a long time ago, 2001, examined 626 patients to see if there's a connection between getting a tattoo and infection with hepatitis C or HCV, and we have the results. So the first thing we're going to do is complete the totals row and column. So 35 plus 17 is 52. 8 plus 53 is 61. 495 plus 18 is 513. And then our totals going across, 17 plus 8 plus 18 is 43. 35 plus 53 plus 495 is 583. And if you add across, add downwards, you should get 626 total, which is good because that's what we wanted. So what percentage of people in the study did not have a tattoo? So something to keep in mind here, our total amount that we're looking at is always after the word of. So what percent of people in the study? Well, our denominator is going to be all the people in the study, which was 626. Out of those people, 513 did not have a tattoo. 513 divided by 626 is 0.819, which is about 82%. What percent of people in the study with a tattoo had HCV? So now our denominator is people in the study that had a tattoo, with a tattoo. So that was 52 plus 61. That's our denominator. And out of those people, which ones had HCV or hepatitis C? And that was 17 plus 8. So we have 25 out of 113, which is 0.221, or about 22%. Probability of tattoo given HCV, our total is after that bar, so that is our total. So looking at all the people that had HCV, that was 43. So that's our denominator. People with a tattoo out of those was our 8 and our 17 again. So we have 25 out of 43, which is 0.581, or about 58%. This next example, I'd like you to pause and try to do this on your own. And if you're like, I'm so confused, I can't, that's totally okay. You can just not pause and just watch me, okay? All right, so 85 students have seen one of 4 new release movies this weekend. We have the number of 11th and 12th graders who have seen these. We want to complete the table. So let's see. We know our total right here is 85. So if we take 85 and subtract out 17, 23, and 26, we get 19. So we're kind of just working backwards here. If we know the total for Cars 3 is 19, and 11 of those were 12th graders, this has to be 8. Let's see, if we add across here 12 plus 15 plus 8 plus 10, we get 45. We know this total in this last column has to be 85, so this is 40. And if we take 40 minus 7, minus 11, and minus 14, we get 8. Okay, and you can always check and just make sure all the rows and columns add up to what they're supposed to be. So now Ms. Songstead, another FST teacher, randomly chooses a student. I'm trying to move this with my finger and it's not working. Let's try. Sorry about that. So Miss Songstead randomly chooses a student. What's the probability that the student saw the movie It? So this isn't conditional. So this is just out of all the students, what's the probability they saw It? So all of the students was 85 of them. Of those, 26 saw It. So 26 out of 85 is our probability. What's the probability that the student saw It or Thor? Again, we're looking at everybody, so all 85. We don't care about grade, which grade they were in right now. It or Thor was 26 or 19. Sorry, that was Cars 3. I'm looking at the wrong value. So we should have 26 plus 17, which is 43 out of 85. What's the probability that the student saw It, given that the student was in 12th grade? So this is our total. So then our total is all the 12th grade students, which was 40. So out of the 40, how many of those saw It? It was 14 going across in the row. So 14 out of 40, which simplifies to 7 out of 20. For the last one, probability, or not the last one, I lied, we have two more, sorry. Probability of 12th grade given It. It is our total, comes after of, or comes after given, or comes after our vertical line there. So our total is all the people that saw It, and all the people that saw It was 26. Of those, how many were in 12th grade? 14. So 14 out of 26, which simplifies to 7 out of 13. Now here's our last one, probability of emoji given 11th grade. So 11th grade is our total. We look at all the 11th graders, that's 45. Out of those, 15 saw the Emoji Movie, so 15 out of 45 is our probability, which simplifies to 1/3.